Hello guys and welcome to another video. What is a drawplate? It's a tool used for making wires. And why I need a wire? Well, I'm currently working on two knives and I think it would be nice to add a little inlay to brass guard. Silver wire will be perfect for the job, but the problem is after one of the previous projects my silver looks like this. It's powder. And also I lack the crucial jeweler's equipment. While I can avoid using rolling mill by hammering, I cannot substitute a drawplate. That's why I'm going to make one. But let's start by turning this powder into something more manageable. After some hammering, I noticed cracks developing on the edges. And it was this moment when I realized that it is the same crucible I used during the making of custom bronze bearings. Therefore I introduced not only copper but also tin into the alloy. And that is probably the reason of fragility. Long story short, I need to clean the silver alloy first. I started by turning the silver into shards, which I dissolved in nitric acid. I precipitated the silver chloride after filtering. Then I converted silver chloride to oxide by sodium hydroxide. And finally, like in every good recipe, just add a sugar to reduce the silver oxide to silver powder. I realized it would be nice to make some fancy silver casting mold, so I drew a simple design and took a piece of scrap steel, which I cut with a reasonable excess and started milling. I followed the project by making a simple clamp. And since I'm already into crafting, I also made a holder for a new crucible of camera. Unfortunately, I overestimated the power of my oxyacetylene setup, so it took me quite a long time to melt all silver. That's why I transferred it into smaller crucible mid-process. Not bad for the first try, but let's try it again. Way better. Some flux is still attached, but not a big deal. Anyway, I tried once more again. And this time I accidentally created a rivet. And after 9 minutes and 30 seconds, it's finally time to make the essential tool. I'm going to use a spring from one of my scavenger hunts on a local scrapyard. It's roughly 20 mm thick and the only flaw is this hole in the middle, but I can turn it into a feature. I nailed the steel after cutting. You can see thick scale developed on the surface. I need to remove them prior any machining, otherwise I can dull my tools. And now it's time to square the stock. And I just turned one big spring into hundreds of smaller ones. Unfortunately, I wasn't lucky enough to find a drawplate blueprint, and I've never had one in my hands, so I came up with my own design. The blank is ready, and now it's time to drill 0.8 to 4 mm holes with 0.1 mm increments. Luckily, I upgraded my drill collection not so long ago, and it made me curious what are the smallest tools I have in my shop. The smallest drill is 0.4 mm, and I feel obnoxious even watching it. The smallest reamer also 0.4 mm. And finally this, believe it or not, this is a boring bar. Since I plan to drill some small diameter holes, I prefer to use my Hauser jig borer. Because first, it has variable speed, and also the quill is quite sensitive. This is the smallest hole, and drilling it is such a smooth job. For simple orientation when drawing, I stamp the numbers of the corresponding diameter. And at this point I have the last machining operation left. A 30 degrees chamfer. I plan to use this small chamfer mill for the job. Finally, it's time to harden the tool. But before I start heating the steel, I need to protect the key areas from scaling. I need to preheat the oil first before the quench. It looks ugly right from the quench tank. However, areas protected by boric acid are nice and shiny. The glass layer is a little bit thicker on the other side, like shards of glass. Unfortunately, some holes are completely blocked. I could chisel it out, but I don't really want to because I could damage the draw plate. Dissolving the boric acid glass will be a safer option. And now it's time for testing. It takes quite a lot of force to work the draw plate at the beginning. You can clearly hear me huffing. Reducing the diameter to 3.0 mm lengthened the wire to 26 cm. Silver work hardens quite fast, see how springy it is. And after a nail, it bends so easily. This clip is obviously speeded up, but it took only 33 seconds to reduce the diameter from 2.4 to 2.0 millimeters. Anyway, compared to the previous measurement, which was 26 centimeters, we are now at 60. It stretches like crazy. I plan to stop at 1.2 millimeters. Guess how long the wire will be then. And it's work hardened again. In fact, I did anneal the wire after every 3 to 4 drawing cycles. I'm just not showing it on camera. Believe it or not, this final draw takes 24 seconds. The diameter is clearly 1.2 mm. But let's see if you guessed the length correctly. And it is an unbelievable 166 centimeters, which means that the length almost tripled since the last measurement. And that's it. From silver solution to powder, from powder to rod, from rod to raw wire, and with the shop-made draw plate to precisely 1.2 mm wire. As always, thanks for watching and till next time.